Hi, Mr. Hasbullah. Our group, which consists of me, Xuan, as well as Albert Pang, Eng Zheng Yu, and Tye Khan Wei, will be presenting on the Computer System Architecture assignment. I will kick off the presentation with the contents we will be covering in this video. I will first be covering the introduction and followed by the IoT system we created for this assignment. Then I will continue with the SDGs that were achieved by the created IoT system. Next, we will be covering the processor that is chosen for this system, as well as its design consideration, which includes structure and function, memory, I/O features, and the processor's capabilities. In today's world, where technology and environmental concerns intersect, there is a growing focus on finding sustainable solutions to global challenges. This assignment delves into the role of the Internet of Things in addressing these challenges. Therefore, we are going to come up with an IoT system that will promote the accomplishment of a few of the 17 SDGs and dive deeper into this device based on its processor type and also design considerations. Now I'll start with the IoT device we created. As the issue of global warming and world hunger is getting increasingly serious by day, our group decided to propose an IoT system that can both monitor the water quality as well as be used for hydroponics. The system is a hydroponic water quality monitoring system, which we named as AquaVert. This system consists of various sensors such as filthiness sensor, temperature sensor, as well as pH sensor. It serves the purpose of continuously assessing and maintaining the health and safety of water bodies in real time by deploying it in small containers of water, as well as big pools of water like in the oceans, lakes, and seas. By ensuring optimum water quality, the system can then act as a device that grows and harvests water plants just like any hydroponic device. Alongside this filthiness sensor, AquaVert also has a filter installed along with the pump body, which is able to filter out all the contaminants to make the water clean again. Besides that, attached with the temperature sensor is a moderator, which helps bring the temperature back to the temperature where plants and fish can live. Furthermore, a neutralizer will be attached to the pH sensor, which is able to bring the pH level of the water back to 7, which will be neutral and safe for plants and fish. Through the implementation of these sensors, AquaVert will be able to support a few SDGs, the first SDG being Zero Hunger, which is SDG 2. By ensuring the availability of clean water, agricultural and aquacultural processes can be done accordingly, as clean water is able to allow plants to grow better and fish to live healthier. Next, the second SDG that can be satisfied is SDG 6, which is Clean Water and Sanitation. AquaVert is able to ensure access to safe and clean water sources, which is essential in many aspects including human health, ecosystem preservation, and sustainable development. Furthermore, AquaVert can also be used to satisfy life below water, which is SDG 14. By detecting pollutants and maintaining optimal water conditions, the system helps protect aquatic habitats and the diverse marine life. Next, I'll pass it on to Albert to continue with the processor we chose for the AquaVert system.
After some consideration, the processor we decided to use for powering the AquaVert system will be the ARM Cortex-M series processor, which will be integrated into an Arduino board. Arduino is a microcontroller, which is also known as a small computer that acts as the brain of a system or device. People often use it to create interactive electronic and robotic projects and implement hardware and software components into it. In this case, we chose Arduino to be the base and platform for our AquaVert system because of its simplicity and ease of use. It offers user-friendly platform for IoT projects and is accessible to everyone. Arduino allows for flexible hardware and software configurations, as most components can be wired through the various pins that are available on the main board. In the future, additional modules can be linked to the Arduino to support more complex systems. The logic of this system can also be set through the use of their Arduino development environment and debugging features. The software for the Arduino is uploaded to the storage of this module, and updates can be developed and used in the future. As for the ARM processor, there are various capabilities that we think are suitable for this project, and we will outline them in later slides. The ARM Cortex-M series processor serves as the central processing unit of the Aquavert system. It acts as the brain that executes instructions and controls the operation of the entire system. It features a reduced instruction set computing architecture, or RISC. This is used with a simplified instruction set optimized for efficient execution of tasks, with it performing one instruction per cycle with high efficiency. Besides that, this ARM processor also has core components such as the Arithmetic Logic Unit, or ALU, for performing arithmetic and logical operations, registers for temporary data storage, and control units for managing instruction execution. The ALU allows for processing sensor data, executing control algorithms, and managing the system resources. Besides that, by implementing physical structures that I designed, such as highly integrated, which is to be able to connect to multiple processors and components and to work successfully together. Also, it is designed to be small and lightweight to be able to fit in small spaces. Besides that, it is also water resistant to protect it from moisture and water. The water resistant feature was done through sealing techniques such as gaskets. In this case, gaskets create a watertight enclosure, protecting the internal components such as the chip and wires from water damage.
Hi, I'm Zheng Yu. In this section, I'll be talking about the detail of the usage of this memory in the processor of the Aquavert system. As you know that the ARM Cortex-M series processor supports various memory configuration, including on-chip memory such as the random access memory, as we know as the RAM, and a flash memory to store program code and data. So the first part I'm going to talk about is the random access memory, which is RAM. The RAM feature in this processor will be the static RAM, which is SRAM, for fast and immediate access to data during program execution. For instance, when the filthiness sensor detected that the water is above a certain level of filthiness, it will store the data in the SRAM, and the filter will be able to execute the cleaning process almost immediately with no delay. The size of the on-chip SRAM can be extended to several hundred kilobytes to store more data that can be executed immediately and simultaneously, allowing more sensors to work at the same time. This can also help in the real-time monitoring of water quality and agricultural health. Additionally, the processor supports external RAM interfaces, allowing for expansion of the system memory using external RAM modules when necessary for larger scale scenarios like in the lake or rivers. The second part is flash memory. Besides it, this ARM processor is also equipped with an on-chip flash memory for storing program code and data persistently. Flash memory is a type of non-volatile memory which rewrites data at the byte level and erases data in units called blocks. It is commonly used for data transfer and storage. Flash memory can help the Aquavert system in storing historical sensor data, playing the data logging role. This data will then be used to analyze trends, identifying patterns, and to come up with solutions to diagnose these issues related to water quality. Besides, the flash memory also enables the Aquavert system to receive firmware updates through direct programming or scheduled updates. This allows for the implementation of new features, bug fixes, and security patches without requiring physical access to the system, enhancing its flexibility and the longevity. Additionally, the RAM Cortex-M series processor also features memory protection mechanisms to prevent unauthorized access while ensuring data and system integrity. In this section, we will be talking about the mechanism used in this processor known as Memory Protection Mechanism, MPU. So MPU, as known as a memory protection mechanism, is a hardware features which divides memory into the distinct section and makes sure that the process is only able to access the memory that is located. This protects the system from malware and other malicious acts through the prevention of accessing the modifying the memory of another process. In the case of the covered system, the MPU allows developers to define memory regions with specific access permission, such as read-only or no access, providing granular control over memory access rights. This was achieved by the implementation of security extension called Trust Zone technology. Trust Zone technology is a hardware-based isolation between secure trusted and non-secure, which is untrusted, region of memory, thereby enhancing system security in embedded applications. Overall, these memory configurations cater to diverse application needs that can be carried out by the processor, ranging from executing complex instructions to protecting the security of the power system. Next, I'm going to talk about the input-output features. So as we know that input-output features in a processor is very important as they are in charge of controlling the data flow between the processor and the peripheral devices. Therefore, the ARM Cortex-M series processor in our cover system offers versatile I/O capabilities tailored to the requirements of its system. So the first part is general purpose input-output, as known as a GPIO. GPIO pins are used to handle both incoming and outgoing digital signals. In the case of the Aquavert, GPIO pins enable the processor to interface with external sensors and actuators, allowing for digital input and output operations. For instance, these GPIO pins can be connected to sensors to receive analog signals representing water parameters such as temperature and pH levels. The second part is Universal Asynchronous Receiver Transmitter, as known as UART. Additionally, the processor also supports specialized communication interface like UART. UART is a protocol for exchange between two or more devices. In this case, it facilitates data exchange with external peripherals, such as communication modules and transmitting sensors data to a central monitoring station or actuators for controlling devices like filters and moderators. After the processor receives the data provided by the sensors, it can be sent these signals to the actuators based on the results from the sensors. Filters will then be able to clean up the water if it passes the level of filthiness or stay put if the water detected is clean. These I/O features enable seamless integration of sensors data collection, processing, and control functions in the Aquavert system, ensuring effective and efficient operations as well as the management of overall water quality.
Hi, I'm Khan Wei, and now I will continue with the capabilities of the Children processor. Firstly, this ARM processor is very scalable and flexible. This allows Aquavert to handle multiple sensors and complex data processing. Besides, this processor has a low power consumption. This allows it to act as a battery to power the IoT device. It can also be of great use when the Aquavert system is used in remote locations, allowing it to run for a longer period. Next, this processor has an extended battery life compared to other processors. This reduces the needs for frequent battery replacements or recharging. Furthermore, the ARM Cortex-M series processor is very affordable due to its inexpensive equipment. This allows it to be used by more people around the world, so that more people can enjoy the usefulness Aquavert brings. Next, the processor also have a high performing speed. This will be useful as the Aquavert system will be responsible for many functions, such as processing data received from the different sensors, controlling their operations, as well as communicating the collected data to the other parts of the system or device, including filters, moderator, and neutralizer. Last but not least, these processors allows additional peripherals, such as an external network card to transmit the sensors data to a central device that keeps track of all data. That is all from us. Thank you.